Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about how to perform the paired samples t-test. We'll be looking at two different approaches to performing the paired samples t-test. Even before I proceed to demonstrate how to perform the paired samples t-test, may I request you to subscribe to my channel, also like and share my videos. What exactly is paired samples t-test? When do we use paired samples t-test? These are some of the questions that we will be addressing in this particular video. When we are talking about t-test, there are primarily three different types of t-tests. The first is the one sample t-test. Second is independent samples t-test. And the third one is paired samples t-test. As the name itself suggests, when we say paired samples t-test, what we are referring to is a pair of variables. Typically, whenever we have a before and after kind of a situation, we can go ahead and use the paired samples t-test. Let me give you a small example to understand the paired samples t-test a lot better. If you want to check whether there is a change in the blood sugar level of a patient before taking breakfast and after taking breakfast, you can go ahead and use the paired samples t-test. Suppose you're a researcher and you're doing performance analysis. You want to check whether there is a change in the performance of the students before training and after training. Again, paired samples t-test can be used. If there is a significant difference in the performance of the students after training, it means that the training is effective. Thirdly, if you are working in the field of marketing and you want to check whether the campaign is effective or not, what you can do is you can check whether there is a change in the response rate of the customers before campaign and after campaign. If after campaign, there is an appreciable level of increase in the response rate, then you can go ahead and claim that the campaign is effective. So whenever you have a typical before and after scenario, you can go ahead and use the paired samples t-test. Let me now begin by introducing you to the data set that I'll be working on. This data set is a fictitious example of patients and the weight reduction program. As you can see here, the first variable that I have is patient ID. There are 16 patients, and for these patients, we are giving a weight reducing drug. The second variable that you see here is weight 0, which simply represents the weight of the patients initially before taking the drug. Subsequently, you again take the weights of the patient after giving them the drug. You can see here weight 1. What is this weight 1? You're giving the drug to the patients for 7 days and you're recording his weight at the end of first week. So weight 1 represents what is the weight of the patients at the end of first week. You continue giving him the drug and check what is the weight of the patients at the end of second week. You do the same thing and check what is the weight of the patient at the end of the third week. And the last variable, weight 4, represents what is the weight of the patients at the end of fourth week. So you have 5 different measurements of weight. What are we interested in doing here? We are interested in checking whether the drug is effective or ineffective. To do this, you have 2 important variables, that is the initial weight and weight 4, which represents the final weight. We are going to take these 2 variables in paired samples t-test and check whether there is a statistically significant difference in the weights of the patients for the final weight and the initial weight. Let me now proceed to move to StatCraft. So this is the software which I'll be using to demonstrate the paired samples t-test. StatCraft P is a tool which uses Python codes at the backend. This is a Make in India initiative, and you will see how easy it is to run a paired samples t-test using StatCraft P. I've already loaded this particular data set in StatCraft P, so there is no need to import the data set. Even before I go ahead and show you the output of paired samples t-test, as a first step, I would like to run the descriptive statistics for this data set. To run the descriptive statistics, let me click on the analysis tab. After clicking on the analysis tab, let me click on the option for descriptives. The first item here is descriptives. Let me minimize this particular dialog box. Initially, you'll be able to see the dialog box like this. I'm going to select all the weight-related variables. So these are the 5 different levels of weight. Once you select the weights, you can click on options and then select mean. This will give me the mean weight of the patients for each week. I'll go back to data and click on OK. In the output window, as you can see, StatCraft gives you the output of the paired samples t-test. Let me scroll down. You can see here, this is the descriptive statistics table. I've got 5 variables, one below the other. Let me begin with the last variable, namely weight 0. Weight 0 represents the initial weight of the patients. The average initial weight is 198 units. Now, let me focus on weight 1. Remember, you are giving the drug to the patient and you are looking at the average weight of the patients at the end of first week. When you look at the end of the first week, approximately the average weight is 196, which means that the average weight has reduced from 198 units to 196 units. Approximately, there's a 2-unit difference in the weight at the end of first week. Similarly, when you look at the average weight at the end of second week, it is 194 units. The average weight at the end of the third week is 192 units. And the final weight of the patients is 190 units. When you compare the first number and the last number, the average weight is 198 and the last number is 190. Approximately, there is a 8-unit difference in the weights of the patients after taking the drug. Now, we are interested in finding out whether this is statistically different or not. Whether this difference that you're noticing of 8 units, is it statistically significant or not? To check for the statistical significance of the mean difference in the weights, we can go ahead and perform the paired samples t-test. To perform the paired samples t-test, let me click on the analysis tab. The second option, in fact, the third option here is compare means. I'll click on the drop-down menu. Here, the first item is t-test. Again, I'll be clicking on the drop-down menu. The second option under the t-test is paired samples t-test. Let me go ahead and click on paired samples t-test. I'll refresh this. You can see here the variables in the data set are displayed in the canvas to the left-hand side, and the canvas on the right-hand side, StatCraft is expecting me to specify variable 1 and variable 2. Weight 0 or the initial weight will go under variable 1. The final weight will go under variable 2. So we'll be looking at the mean difference of initial weight and the final weight. Once you make these two selections, all that you need to do is click on the OK button. Again, you can see here, the output is ready. The output of the paired samples t-test is what we need to study. Let me scroll down. This is the output of the paired samples t-test. The t-statistic value is 11.17. What is the p-value here? The p-value is 1.14, into e power minus 8, which is a very, very small value. It is clearly less than 0.05. We take the p-value and compare it with the level of significance. The level of significance here is 0.05. So the p-value of 0.000 is clearly less than 0.05, and therefore we can go ahead and reject the null hypothesis and conclude that there is a significant difference in the weights of the patients before taking drug and after taking drug. And hence, you conclude that the drug here is effective. Let me now go on to the data option. This is the source data. What we have done at this stage is to compare the initial weight and the final weight. One additional question that you might want to probe here is, from when does the drug actually begin to take effect? Some of the drugs take effect after some time. Other drugs begin to show effect very quickly, or immediate relief is what you can expect. So we have concluded that the drug is effective, but the question here is, does the drug begin to take effect in the first week, second week, or the third week? So to check at what point is the drug effective, what I can do is I can do one more level of paired samples t-test between weight 0 and weight 1. Let me again reopen the analysis tab, go to compare groups. Here you can see the first option is t-test. In the drop-down menu, I'll be choosing the option paired samples t-test. I'll remove the variable weight 4, and instead of weight 4 as variable 2, I'll be choosing weight 1. What this does is, this makes a comparison between the initial weight and the weight at the end of first week. If there is a significant difference in the weights of the patients from the first week, from the initial weight to the end of the first week, we can go ahead and say that, yes, the drug shows effect immediately. Else we have to conclude that no, the drug is not taking effect immediately. It is taking effect after some time. I'm just going to choose weight 0 and weight 1. There is nothing else. There is no other option that we need to specify here. And we can go ahead and click on the option OK. You can see here when you scroll down, the t-statistic value now is 3.6 and the p-value is 0.002. 0.002 has to be compared with the level of significance. So 0.002 is clearly less than 0.05, and hence again you'll reject the null hypothesis and conclude that the drug is effective and it has shown effect in the first week itself. So this is very, very interesting, because this proves, the statistical analysis clearly shows that the drug is beginning to take effect in the first week itself. The third question that you might be interested in asking is the drug able to sustain its effect? Is the effect of the drug long-lasting or is it short-lived? For this, I can go ahead and do another level of paired samples t-test. To do this, let me go ahead and open the analysis tab. Choose the third option, compare groups. Here, I'll be selecting t-test. Let me click on paired samples t-test. Now you can see here the paired samples t-test dialog box opens up. Under variable 2, instead of selecting weight 1, I'll be selecting weight 2. Let me now click on OK. Scroll down. What you're doing with this pair is that you're comparing the initial weight of the patients with that of what is the weight after 2 weeks. Clearly, you're able to see that the p-value is very, very less, 1.11 into e power minus 7, which is clearly less than 0.05. And hence, again, you can go ahead and conclude that the drug shows effect at the end of the second week also. So this is how you can perform the one sample. This is how you can perform, my apologies, the paired samples t-test. Now, we've seen how to perform the paired samples t-test. I've shown you how to perform paired samples t-test for 3 pairs of variables. Is there an alternative approach to performing the paired samples t-test? Let me now show you approach number 2 to perform the paired samples t-test. In approach number 2, what we will have to do is we'll have to manually calculate the difference in the weights for any pair of variables. Let me begin by calculating the difference in the weights for weight 0 and weight 4. To compute this difference, I'll be clicking on Analysis tab, then Descriptives. Sorry, Descriptives is not the option. I'll have to go to the first option, Data. Here you have different options. I can choose the second item from the top, which is called as Prepare. Under the Prepare section, the very first option is Derive. Let me go ahead and choose the Derive option. As you can see here, this is a new dialog box that you have. In the new dialog box, what you can do is you can derive a new variable. This variable I'm going to call as difference. This variable represents the difference. I'll have to type a simple formula here under the formula section. Let me click on the formula section. This opens up a new dialog box. This dialog box is called as the expression dialog box. I'm going to specify a simple formula, that is weight 4 minus weight 0. So this is a very simple subtraction that I'm doing between the final weight of the patients and the initial weight of the patients. To validate this expression, I can click on the validate button. You can see here, once you click on the validate button, the OK option gets enabled. I'll click on the option OK. So this is the formula that will be used to calculate the difference in the weights of the patients. I'll now click on the option OK. As you can see here, a new column has been created. This column is called as the difference column. You can see here for the first patient, it is -6. It is -6 because we are taking the difference of 192 and 198. The difference between 192 and 198 is -6. So this difference is what StatCraft is displaying. Now, if you want to calculate whether the mean difference is significant or not, instead of following the paired samples t-test approach, you can go ahead and use the one sample t-test for the difference variable. Let me now click on the Analysis tab. I'll go to the option Compare Groups. The first item here is t-test. There are different options under this section. I'll be choosing the one sample t-test. I'll not be doing the paired samples t-test here. I'll be doing the one sample t-test on the difference of weights between the final measurement and the initial measurement. As you can see here, this is the dialog box for one sample t-test. At the right side, I have to specify the variable for one sample t-test. Let me choose the last variable, namely difference. Here I'm checking whether the difference in the weights equals 0. Let me now click on the option OK. I'll scroll down. You can see here the table for one sample t-test. There are 3 columns. The first column is the variable that we have selected, which is simply the difference. This is the one sample t statistic value, which is -11.17, and the p-value here is 1.14 into e power -8. What does this mean? This simply means that when you look at the p-value, it is very, very small. How small? It is smaller than 0.05. Since this value of p is less than 0.05, we can go ahead and conclude that we will be rejecting the null hypothesis. Once we reject the null hypothesis, we conclude that the difference in weights is significant. Since the mean difference in weights is significant, we can say that the drug is effective. With this, I have come to the end of today's video. In today's video, we have seen two different approaches to performing the comparison for dependent samples. One is the obvious choice of the paired samples t-test, wherein we have to compare between a pair of variables. The second option here is to look at the one sample t-test. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much. Have a great day ahead.